Okay, this is the third lesson on differentiation. So just a quick recap to start with. How do we differentiate harder expressions? If we have any roots, we will turn these into powers and then differentiate as we usually would. Watch out for combinations such as being in the denominator and also being rooted at the same time. Unfortunately, sometimes when these questions are printed, you will sort of see something like this, perhaps. So sometimes on the printing, the fraction bar and the negative can go together. Split up fractions, we talked about this last lesson. You can effectively sort of do this fraction plus this fraction, okay? And when you simplify, you should get this here. Expand out any brackets, and then when it's in this form, it should be straightforward. Numbers in denominators, you have to be very careful with this. So 1 over 3x is the same as saying 3x to the minus 1, because 3x is put in the denominator. Remember, when you sort of apply the power, what you do is you do it to each. So this is the same as this, which is the same as a third x to the minus 1. Or an easier way of doing it is perhaps thinking of multiplying fractions backwards. This must be the same as this here, because if you multiply them, you'll get this result. Okay, so if you do it this way, I think it's easier. Pull it out into two fractions multiplied by each other, and then keep this one in index form. Okay, pause the video on board there and just have a quick go at putting those ideas together, just to check that you're comfortable with them. So let's have a look. Two things going on, the root and the denominator. Make sure you got both of them. And again, don't forget to actually differentiate at the end. Splitting it up into two fractions, write it in index form, and differentiate. And here, tackle the denominator first, split it up into two, and differentiate. Okay, and there's a couple of questions there on the board for you just to practice the idea a little bit more. So pause the video here if you need to have a bit of extra practice, and I'll reveal the answers. Okay. More challenging practice? Yeah, I think we've sort of covered those ones already. So what's one of the applications for this then? Well, if you remember back to straight lines, we said to find a straight line, we need some coordinates and we need a gradient. Well, if we are differentiating to find the gradient and we're using an x value to do that, we could get the y value as well from the original. So we have everything we need to find tangents, for example. So we need a point and we need the gradient. Now we have y equals x squared. The gradient function, dy dx, because remember, dy dx is all about finding the gradient of a line. Yeah, that's ultimately what it's all about. The rule is you can do 2x. We want to find the equation of the tangent when x equals 3. So that's fine. We'll put 3 in there. And we'll get 6. So we've got, well, let's write it down. Y minus y1 equals mx minus x1. So I know that this here is 6. And I know that happens when you use 3. So what's missing? Well, I need the y that corresponds with the 3 as well. If you are looking for a y value, you need to use this top equation because this links x and y together. So x squared, well, that's going to be 9 then, isn't it? So y minus 9 equals 6 brackets, x minus 3 close brackets. Okay, and we could, manipulate this further if we wanted to. Perhaps put it in integer form, ax plus by plus c equals 0. So that was a tangent. because a tangent just touches and it's the gradient at that particular point there. What about a normal? A normal is at right angles to a tangent. Now, if we write our equation in this form instead of y equals mx plus c, it's great because the only thing that's different about the normal line is the gradient. The 3 and the 9 from before are exactly the same. So if the gradient of the tangent is 6, what's the gradient for the normal? It's the negative reciprocal. And we can easily, very quickly, find the equation of a normal from our earlier equation of a tangent if we write it in y minus y1 form. The thing you need to be careful about then here is tangent and normal. A tangent, okay, has the same gradient. It just sort of follows off. A normal is the one that is perpendicular to a tangent. Pause this slide here, have a go at the question, and just make sure that you are finding the line using the correct gradient. Okay, so I'm assuming you've done that. Here they've started with the coordinate this time. So we're trying to do everything from when x equals 9. The corresponding y is 18. Just the gradient now. What have they chosen to do? So they've chosen to differentiate here, to plug in, where was it? To plug in 9 and to find the gradient of the tangent. That's why it's t. You can then do the negative reciprocal to find this one here. So 1, 2, 3, plug them all in to the equation. Okay, and that takes us up to part 12F.